Errors in construction: not providing top reinforcement, inadequate anchorage length, incorrect cranking of reinforcement, lap positions, correct lap length. We need to discuss what are the correct methods you need to follow. I am Prasad from Structural Guide. You are welcome to the Structural Guide YouTube channel. Please subscribe our YouTube channel. You may get the notification on new videos. Mistakes you made at the sites: not providing the top reinforcement at the edges. No top reinforcement provided at the continuous edges, that is at supports. Inadequate anchorage length. Incorrect cranking of rebar. Lapping of top bottom reinforcement at the mid span. Inadequate lap lengths. Let's discuss each type of these defects in detail. Missing top reinforcement bar. You can see here I have indicated the missing top reinforcement bar. Most of the time we can see this reinforcement bar is not provided at the beam edges. This is slab, you can see this is the slab we are referring. So this is a beam. So bottom reinforcement we provide like this. Then you don't provide the top reinforcement most of the situations I have seen. This is a construction error. What is the correct method? You can see here in this figure the top reinforcement need to provide at these edges. So you can provide a U bar like this. The bottom rein bar can be continued like this. If you don't have adequate length to continue around this, you can provide a separate U bar and lap the bottom reinforcement here. Or else you can provide both bars separately. So bottom reinforcement you can bend upward, so with the adequate anchorage length there, and the top reinforcement you can bend into the beam. This is also possible, but this is the best way because there won't be any error. So you provide the U bar like this. You can see in the site here this figure. As I explained, this bar is provided here, but top reinforcement is not there. So this is an error that people made in the construction. Therefore, at any support you have to make sure there are top reinforcement in the slab. This may have specified in the drawing. Whether it is in the drawing or not, we have to provide it. This should be due to an error. It may not be in the drawing, but at any case, you should have to provide the top reinforcement unless this slab is simply supported slab. Missing top reinforcement bar. You can see in the figure there is no top reinforcement bar here. This is missing. When you have a support in a slab, support is beam. Mostly these slabs are supported by the beams. In a support, you have to have a top reinforcement because the bending moment diagram will be like this. You have a hogging moment here. So if you have a hogging moment there, you have to have a top reinforcement. At the midspan, you have a sagging moment. There you have to provide the bottom reinforcement. At the support, you have to provide the top reinforcement here. How do you provide that? You can see in this figure, you have correct way of providing the top reinforcement. This length may be vary, but from support edge to this point, you have to provide the top reinforcement. Generally, this length is about 0.3 times span. Most of the time, 0.34 times the span of the beam is considered. But there may be slight variation there. But depending on your standard. But you have to keep in mind, whatever the standard use, you must provide the top reinforcement at support. You can see in this figure also, you should have a top reinforcement here, but they are not provided. So this is a construction error, and there may be chances of structural failures if you haven't provided top reinforcement. In a span like this, there will be considerable hogging moment there. If you don't have a reinforcement there may be a crack like this, then slab may collapse. There are chances of collapsing slabs if you are not done it. Inadequate anchorage depth. Sometimes we have seen this top reinforcement bars are provided, but it's like this, not anchored into the beam correctly. Now to take this reinforcement bar to that applied tension, this should be anchored, otherwise it will pull out. If this tension is developed there, this will pull out due to the inadequate anchorage length. How do we provide it? As we previously discussed, so you have beam reinforcement here. So from this point, you need to calculate the anchorage length. So this length is the anchorage length. Now when you continue by like this bar is continuously anchored. Therefore you don't want to do anything, because naturally its anchorage length is generated. But in this case, now top reinforcement bar is not continue like above figure. So you anchor into the this beam. So we have to provide the anchorage length from the restraint bar. This is the restraint bar. This is the H beam reinforcement. From that, you have to provide this anchorage length. This is called the tension anchorage length, because this bar is provided to take the tensile stress, because we have a hogging moment there. So therefore you have to provide the tension anchorage length there. You can see here in this figure also, in actual construction, this is the top reinforcement bar. It's bent into the beam. So this point onward, you have to calculate the anchorage length. From this point onward, you have to calculate. So this length should be the tension anchorage length. That required length as specified in the standard, you have to provide. Incorrect cranking of reinforcement. Sometimes you can see in the construction the top reinforcement bar need to crank due to a level drops. So your slab is drop here. The level drop is there in the slab. In a such case, we have need to provide the crank. But some people, what they do is they bend the reinforcement like this here. If there is a sharp bend, this is not acceptable, and this is not correct way of doing it, because when the tension is applied, this bar can straighten up, because when this tension is applied, this bar can move this way. It won't be able to take the tension. Let's see these figures. Here you can see they have done cranking up to certain extent, but this is also not correct. The cranking should be done within the beam reinforcement or within the beam. You can see here the crank is somewhere there outside the beam. So this is not correct. But you can see here this bar is correctly cranked, but some of the bars is not correctly cranked. Also their crank is not accurate. You can see here this bar is going like this, so this is not correctly cranked. So here you can see different bends, so this is also not correct. The correct cranking should be done when you do provide the top reinforcement like in a level drop. You can see here in this figure also, as we shown here, the bar is bent like this, sharp bend is there. This bar cannot take tension, because when you apply the forces, this bar could, when it is stressed, move this way, because when it done bend, therefore it could fail. Therefore we have to be very careful, especially when there are cantilevers. We have to be very careful when you doing the reinforcement detailing and when you do the construction work. What is the correct method of doing it? So you can see here there are two methods I have shown here. What you can do is top reinforcement bar, you can continue like this, then you can provide the U bar here. So this is one of the simplest way you can do it, because you don't want to bend any reinforcement. You provide a U bar there and you can continue this bar. When you have a considerable level drop there, this method is more suitable. So adequate length for this bar you can provide it depending on the cantilever or continuous slab. This length you can determine based on the boundary condition of either slab. Or else, as we discuss here, you have to crank reinforcement like this. Cranking can be possible. The bottom reinforcement bar you can send like this. This bar, if there is a level drop there, if you can't crank it, this bar you can bend like this. Now here the correct way of cranking. So we have to maintain the crank within the beam. So you have crank within the beam. So That has to be done. So then you can continue this bar as you wish. Lapping at the midspan. This is also incorrect. So you have provided the top end portion, but you have provided the lap here. This is not correct because in a slab, as we discussed, there will be hogging moment here. So there will be hogging moment there. Then midspan there will be a sagging moment. Here you have a sagging moment. Okay. Now if you have a sagging moment there, then the reinforcement are critical here, the bottom. So bottom reinforcement are critical at the midspan. Top reinforcement are critical at support. Here you have hogging moment, so therefore top reinforcement you need to provide their support. At the midspan, you have to provide the bottom reinforcement, and maximum tension stress will be at the midspan. So therefore you don't allow to lap here. If you have a lap, that create a weak joint. Therefore you should lap somewhere here or somewhere there. Close to the support, you should lap the bottom reinforcement. When you lap the top reinforcement, if you have a double neck, you have to lap close to the midspan, away from the support. You are not going to lap close to the support. If you want to lap top reinforcement, you don't lap close to the support. Therefore, you should not do like this. In this slab also, you can see here they have done lapping. They have fairly high lap length as well, but this is not correct method of doing it. You should not do the lapping at midspan. Some of detailing I have shown here for standard practices. You can see here you have lap at close to support. Then you can see the continuation of the reinforcement bar. If you need to double net, you may use a different method, because depending on the this span, there may be hogging moment throughout this span like this. So you may have to provide the top reinforcement, since this phase have a continuously tension from this support to this support due to the high span here, or else you might avoid the, if this is span very large, you might not need to provide the top reinforcement. Likewise, you can see here you provide the bottom laps there. So some restraint edges you can continue bottom bar, and you can provide the U bar like this. So some cantilevers you can provide the continue one U bar like this. For best for standard detailing, and the best way of detailing is that you may provide the restraint bar like this to hold the U bar in that location, because you have a link in the links in the beam, so you can fix this bar to the link. Then this top reinforcement of the cantilever is restrained well. Those things you can use in the standard methods or the correct method. It's not must to have that distribution bar always, but if you have fairly large cantilever, it's advisable to have a distribution bar tied to the link like this. With that, we end the today discussion. Let's meet again from new video. Thank you very much for listening and watching our videos.